What is going on, everybody? Dan Tramte here, and welcome back to my tutorial series, Browser Noise. This is tutorial number 11, and I wanted to move on from this project, but there are a few things that we should optimize to make this run a little more efficiently. So first of all, let's jump down to this line of code right here. So inside our nested for loops, we have let many angles equals cosine, blah, blah, blah. Its responsibility, if you remember, is to set the phase for each column, keyword there, column of particles. And right now, look where it's sitting. It's inside our nested for loops. So it's running too often. Let's think about that. We're running this in its current configuration. This for loop is running 20 times per frame, and for each of those, it's running 10 times for the Y value. So that's 200 times per frame, and we are inside the draw loop, which is is attempting to run 60 times per second. So we are running this line of code right here, 12,000. Yeah, 12,000 times a second, and that is way too often. And the issue is that we are running it every time we set a Y value. We don't have to do that. We just need to run it every time we set an X value. So a really, really, really easy way to optimize that is to cut. And instead of having it in our nested for loop, we just have it in our X for loop and let it run, and it should still work. Yes. Now let's do it this way just to double check. Whoop. Yeah, still working beautifully. Okay. Very good. Part 1 done. Next thing I want to do is super simple, and it really doesn't do much to optimize it, but it's just something that's bothering me. So when we are setting or generating our array of phases, one thing I did, I don't know why I did it. I have this offset of a width of 2. I think I was just like trying to imagine everything shifted over, over this way, so that it would make sense in my head. But really, we just need to have it go from 0 to width over 2. Part 2 of optimization and cleaning done. Next, if you remember, when we first generated our particles, we generated enough that it would sort of fill out the entire width of the canvas and the height. And then all we did was we shifted it over. And there's a little bit of issue because we have particles being calculated but not displaying because they're sort of off screen. So I'll tell you, that's not a big problem. I'm not going to fix it, okay? There are things we can do, like, for example, multiply each of our for loops by 0.5. So where's the other X for loop right here? 0.5 times, and it should be okay, you know. Let's give it a low frequency. It looks great, and there are now no extra columns being generated. But notice what happens if I mess with the amplitude. There's actually a column that ought to be appearing over here that isn't. So that's a bit of a problem. Also, I don't like putting non-integers into our for loop because if we make a cell that is 21, I think it'll work because JavaScript just likes to work just fine. Yeah, it totally works. But it's not a good idea because we're generating an array over here, and the array indices are supposed to be like 0.5, 0. Whatever, and that's not great. So there is a fix for it, floor doing something like that. So which always rounds down to the nearest lower integer. We could do something like that for both of our loops. I'm not going to do anything because here's the thing. I'm I'm just going to allow it to generate more, because even if we did something like 0.6 to account for that extra column, let me convert or revert all these back, and then do 0.6. Even if we did 0.6, let's do that. Low frequency, high amplitude. Then we are accounting for those extra columns, but you might like choose to do some ridiculous settings, like instead of having our cell be 20, what if it's 4? Let's see what that looks like. Yeah, ooh, that looks kind of cool. Oh, yeah, it's playing. Go down here. High frequencies. Okay. We did enough. Okay. I was hoping that we would see that there was a little bit of space over here and where columns weren't generating, but 0.6 seems to work just fine. Let's go back to 0.5 just to show what I was hoping we would see. 5, go, boom. Come on, move. There we go. And yeah, see, there are all these particles not generated. Okay. I'm just going to leave it as it was, because here's the thing. Yes, those columns are being generated or calculated, we'll say. But to be honest, that's not what's really going to be hogging up the system. If it's attempting to draw off screen and it doesn't, that is not adding that much overhead, or it's totally fine. The thing that really bogs down the system is actually drawing those particles. So I'm just going to leave it as it was. Also, just to account for some ridiculous settings that we might enter. Okay, so let's also real quick set the cell back to 20. Okay, very good. Part, what was that? 3? We didn't do anything. I just blabbered. Done. Okay. Last thing I want to do, and this is probably the most important thing of this tutorial. So if we look down here in our draw function, we will see the following 4 lines of code. Okay. This entire time I'm talking, since those lines of code are in the draw loop, they are happening 60-ish times a second. And the thing is right now I'm not touching the sliders, and that's what's supposed to happen. When I touch the slider, this amp changes. When I touch the slider, this frequency changes over here. That's what's supposed to happen. But 99% of the time, I'm not touching the slider. The sliders are events. It is an event that a human being interfaces with the slider. So the issue is, why not let events be events and draw animation things be draw animation things? Okay, so what we need to do is we need to create event listeners for both of those sliders, okay? And we need to create functions that run every time those events occur. So let's do that. So let's go up to the setup function. Okay, so somewhere around here, it doesn't really matter. We are going to create an event listener for each slider. So we're going to call the sliders by their names that we made for them. I have my caps on, amp slider. The type of event that we're going to do is input, which is what we would typically do for sliders and also text boxes. Okay, so we're going to make an event listener for each of those. So the other one is frec slider, of course, dot input. Okay, and then inside these parentheses, we're going to write the name of a function that we are going to create. And this is the first time we're going to create a function. So this is exciting. Okay, so what I want the function name to be is update amp, something like that. And then update frec. So right now, nothing's going to happen. We have to create the functions. So let's go down here at the very end. This is another thing. I think they can sit anywhere, but let's put it at the very end. Okay. And we are going to make a function. We say function. And then we use the name update amp. And then we open and close parentheses, open and close brackets, braces. And then we're going to make another function called update frec. Okay. And what is our function supposed to do? It's supposed to do anytime we adjust the amp, we're going to set the amp variable, and anytime the amp variable changes, this os.amp, our oscillator is going to change. Our oscillator value is going to change. Okay, and then same thing with frequency here. And I'm doing this one at a time. Okay, this one right here goes down here. Okay, now let's just for safety comment those lines out. Press stop, press run. Will it work? Yes, everything works beautifully. And just to further explain a little bit, these two lines, these event listeners that we created, what we did here is we're just telling the browser, hey, be on the lookout for any time the user moves these sliders or updates these sliders. And when they do, run the function in here. So that means these lines are being run according to which slider is manipulated. And that is all I wanted to do. We are done with this project. We are moving to the next one in the next tutorial. I will see you then later. Bye.